Hi, welcome back. So in this section, we are going to talk about providers. What is Terraform Providers? We'll talk about the overview of providers, how to write the provider block, how Terraform find and fetch the providers, how to manage the provider version, what are the authentication methods we do have with Azure Provider, and how we can configure the multiple providers, like if I wanted to deploy resources in Azure and AWS together from the same configuration file, then how can I use it? Or if I wanted to deploy like resources in a multiple subscription, then how I can use multiple providers at the same time. So we'll see how it works with the areas. This is what we are going to talk about in this section. Let's have a look to the providers overview. We'll talk about what is providers, what comes in our mind when we talk about the Terraform providers. So let's have a look. Let's assume there is a configuration file and there is a code which we would like to execute, like a Terraform resource block, which we already talked about, the block thing. So here let's assume I do have a resource block which is supposed to deploy the resource group in Azure in my subscription. Then how it works? What are the role of the provider here? So whenever we are writing a configuration file in Terraform, we are also writing a provider block. And when I say the provider block, basically we are indicating where this particular resource block should execute, where it should go to deploy the resources. So I have written a configuration file to deploy a resource group in Azure. What it will do is, it will go to the HashiCorp registry. So there is a registry hub in HashiCorp where we do have all the providers. We do have the providers for AWS, GCP, and many more. And Azure, AWS, GCP, they are the like official provider available over there. In short, if I say what or how the provider works is, so I'm sure you guys know, like there is a way in Azure to deploy the resources through the API as well. Apart from PowerShell, CLI, or the portal, we can also deploy the resources in Azure using the API calls. And you can see the documentation of that API calls in Microsoft documentation. But if you go through it, it's a tedious process. It's not a user-friendly process. Like you have a URI, first you have to generate your bearer token for the authentication. Then you provide all the header, body, and all the required parameters to your URI. And then you make this post API call or get API call if you just wanted to read it, or if you want to deploy something, then you do the post. If you want to update something, then you do the patch. If you want to delete, then you do the delete call. But if you see the format, it's not a user friendly at all. You can't remember it. It's not easy to write. It's not that helpful. Okay. What Terraform is doing is, Terraform have this provider, which is also a plugin, or we can say it's a plugin, where Terraform is converting the configuration file or the HashiCorp coding language format into the API call. So even though we are writing the code in a HashiCorp language, like in a simple resource block format, it will getting converted with the help of the provider or the plugin in a form of API, and it will just trigger the API call to the Microsoft or the Azure, and it will deploy the resources. So basically, provider or what Terraform is doing is, Terraform is converting the way of writing the code, or the way we are writing the code in a HashiCorp language. It will just convert that format into the API call and trigger it. And apart from that, it is also doing the expression thing, conditional expression thing, or if statement and all those things. And as well as it is making sure like the call which we are doing, the API calls, it's in a proper format and it can trigger and all other things. So it's not just like it's converting it, but many more. But the main purpose of this provider or the Terraform is like making it simple. The one of the benefit of the Terraform is to making it simple to write the infrastructure as a code in a simple format. And provider is a plugin which convert this code in a API format and trigger it to the Azure and deploy the resources. So this is what the provider is doing, or this is what the provider is. So whenever we are deploying the resources through the Terraform, first thing we have to mention is like which provider or which cloud you are gonna use. So based on the provider you are selecting, the cloud is comes into the picture in the Terraform. So if I use the Azure provider, then that means I'll deploy the resources in that particular configuration file to the Azure. If I use the AWS, then it will be AWS. And if I use the GCP or Kubernetes or any other thing, then I can use their provider. Similarly, with this provider, it's a package. And I'll show you why I'm saying it's a package, because when we run it, it is basically getting downloaded to our environment. And I'll show you how it looks like. So it's a package. And when it's a package, then it does have the version. And we'll see like what are the versions of the provider and how to upgrade it, how we are managing it. And why we do have the version is because with the Azure API, we do have the different versions. So let's assume there is a new things introduced in the Azure, like a new field or something. They are updating the API calls. Similarly, the provider version in Terraform is also getting upgraded. So we talk about a more in version management, but provider is a package which is helping to convert the Terraform configuration file into the API call, triggering it and deploying your resources. And based on the provider, we can decide which cloud we are working on or how we are working on. So that's all about the providers overview. Let's have a look to the next topic, how to write the providers block. So we talked about the providers overview. I hope we know what is the purpose of the providers, and the very first thing which we have to do with the providers is we have to write it as a provider block. And as I have mentioned in the Terraform syntax, that everything in Terraform we are writing in a block format, and that's why I'm calling it a providers block. So let's have a look how to write a provider block, because that is the first thing you have to do when you start writing the configuration or Terraform configuration file. Because in the very first, you have to mention like which cloud you are going to interact with or you are going to deploy the resources in. So let's have a look. So this is our Visual Studio Code again, and I hope now you understand it better, as we already saw that how to install and configure the Visual Studio Code. Generally, we can have this provider in a main.tf file or whatever the file we want, but a good practice is to keep the provider in a separate providers.tf file or provider.tf file. The first thing we have to write for the Terraform provider block is the block type, and the block type here is provider. Then we have to mention which provider. So now we are going to talk about the Azure mostly. So it will be a Azure block or Azure provider. If you want to see for the AWS and GCP, you can always refer the Terraform documentation to see how to write the provider block for AWS or any other cloud. But for Azure, this is how you write it. Then as it's a block, then you have to use the curly braces. And with Azure provider block, we do have a few things which we can mention. The very first thing is the features, which is mandatory. Even though if you are not mentioning anything into the features, still you need to write the feature block. And I'll let you know what we can mention in the feature block. But feature block is necessary. Even though if you are not using anything into it, you have to write a blank feature block over there. Because in the Azure provider block, we do have some settings which we can use. Like we know Azure offering a public services as well as government services, German special or China special. So we can mention like which particular Azure services you are gonna interact with. So here let's assume I wanted to use the German based, so I can use the German. If you want to use the generic one, the public one, then you don't have to mention anything over here. Similarly, there are a few more settings which you can always refer with the Terraform documentation. You have like some parameters called storage use Azure AD. We want to set these settings as a default for this particular provider, for this particular configuration, whoever is using the Azure provider in this configuration file. So we can set up some like a basic setting or the default setting, or we can override those default settings. But in most of the cases, like in my experience, I never override or I barely override those settings. We are always keeping it default. Now let's have a look what we could use in the feature block. So if I go to the feature block, let's assume there are few settings in the feature block which I wanted to override. So by default, what Azure is doing or what provider block is doing, it's not deleting the disk, okay, of the virtual machine if it is not in the code. So I want whenever the virtual machine is getting deleted, I want it to delete the OS disk as well. So I can override this setting. If it is default is false, then I can make it true. So whenever I'm deleting the virtual machine through the Terraform, it will delete the disk of the virtual machine. Or if I wanted to do the purge soft git on destroy, so whenever I'm destroying the keyword, it should also be purge. It's not a good practice though, both of them, but Yeah, that is the example, like what you could do or what default settings of Azure Provider block you can override with the help of the features. And for rest of the features or rest of the details of the features which you wanted to override, you can always check into the registry.terraform.io, and you can go to the providers and search for the Azure RM and see the documentation for the provider block. So if you see this provider block, we do have the type of the block, that is provider, the name of the provider, that is Azure RM, and then we do have feature and other parameters or arguments where we can override the default settings in this particular provider block. Now let's see, as soon as we write the provider block, the very first command in Terraform we are going to execute is Terraform init. Terraform init is a command which is basically downloading the provider or fetching the provider. So if I execute the Terraform init, what it will do, let's have a look. So if I do the Terraform init, it is basically, if you see, initializing the backend, and then go to the initialize provider plugin. And if you see the line where we have mentioned provider version, it is installing HashiCorp/Azure RM. That means it is using HashiCorp as a registry and Azure RM as a provider. And we did not mention any version over here, so it took automatically the latest version, that is 3.82.0 at that time. And if you see the next one, it is signed by HashiCorp. That means it's an official HashiCorp provider block. On the left side, if you see, there are two files, or one folder and another file are over there, which was just generated after running the Terraform init command. In that folder, you see .terraform, and that folder we do have the provider, the package itself, which I talked about. And the second file is .terraform.log.scl, which basically has the hash thumbprint of that particular provider, just to make sure the provider which we have downloaded is the authentic and genuine one. And I wanted to make sure that whenever I'm running the Terraform init for on this particular folder of a Terraform configuration, it should always match with the provider. So these two files are getting downloaded as soon as we are running the Terraform init. So yeah, that's all about the Terraform provider, and now we are gonna see how Terraform find and fetch the provider in a practical way. So let me show you. Thank you. In this graph, I'll show you how Terraform is finding and fetching the provider. We already talked about what is the provider and what is the importance of the provider in the Terraform. And as I have mentioned, like, provider is the backbone of the Terraform. Provider is the only thing which is connecting your cloud. So each provider has its own cloud authentication and mechanism to integrate with the dedicated cloud. So if I do have Azure, then I can use the Azure provider. If I'm working on a GCP, then I can use the GCP provider or AWS. So whatever the cloud provider I wanted to use, I can use with the Terraform, and I can integrate it in my code with the help of this provider block, which I already explained, like what type of options we do have. There is one more thing which I would like to mention here in the lab, because when I was recording the slides and the animation, the provider was not needed subscription ID. It was optional. This parameter was optional, but with the Terraform provider version for Azure 4.0 and onwards, it requires the subscription ID. So now the subscription ID is a required parameter. So without subscription ID, you will not be able to do the Terraform initialization. Okay, so going forward, it's not optional, but a required parameter. So whenever you are writing a provider block, you have to mention the subscription ID and the subscription ID of your subscription where you want to deploy the resources. Okay, so here I do have the simple code which we are already using from last couple of sessions. So this code does have the provider Azure RM, and there is a features block. I don't have any configuration in the features block right now, but I do have the subscription ID where I have mentioned my subscription ID, and then this whole code will deploy a resource group and the virtual network, but we are not going to deploy it in this session. We are just going to see how the provider is fetching and downloading when we are running the Terraform initialization command. So to execute the command, I already explained we have to be in the same folder. Otherwise, we'll have to explicitly mention where do we have the code. But in our case, we are fine. We can use the same folder itself. So I'll just open the integrated terminal with this folder. As I have mentioned in my previous session in the Visual Studio Code, that Visual Studio Code is very easy to handle the Terraform task. So I can just simply right click on it and do the open in integrated terminal, and my terminal will be open here. So to find and fetch the provider, what we have to do is we have to run the Terraform init command. Terraform init command is basically an initialization of your code. And Terraform init command is basically searching for your provider block in your Terraform code, and based on your provider, like we are using the Azure RM here, it will find and download the Azure RM provider here. So far, I didn't mention any version or anything here in the provider block, which we are going to discuss in the next session or next topic, that how to manage the provider version. But so far, I didn't mention any version of the provider, so it will fetch and download the latest available version of the Azure RM provider. So let's execute the Terraform init command. If you can see here, finding the latest version of the HashiCorp Azure RM provider. Then it finds the latest version is 4.228.0. So it is installing the Azure RM HashiCorp / Azure RM version 4.28.0. And it might take a few minutes because this provider version or this provider itself, it's sometime maybe 100 MB or 150 MB or something like that. So it might take a couple of minutes, and based on your internet speed, it might take a minute or two to initialize the Terraform init command and finding and fetch the provider. So let it complete and then I'll show you. Yeah, so it is completed. Now if you can see here, installing it, install the HashiCorp, signed by the HashiCorp. That means it's a this provider is the original one, and we have to make sure like we are following or we are downloading the provider which is signed by authorized organization like HashiCorp or Microsoft or something like that. Otherwise, there might be possibility there are some malicious provider, because the Terraform is open source and people can write their own providers and they can publish it. So you can have your own provider as well. But if you are downloading any provider, just make sure you are downloading or you are installing the right one from the right registry. So we are downloading it from the HashiCorp. We didn't mention any registry, so it's by default HashiCorp Azure RM, and it's signed by HashiCorp. And you can see Terraform has created a log file .terraform.log.scl, which we can see here on the left side in the same folder, to record the provider's selection it made above, including this file in your version control repository so that Terraform can guarantee to make the same selection by default when you run Terraform init in the future. So if you are using like a Git and the code repository for the version control system, it is advisable to use the same file in your code repository. So next time when you are running the Terraform init command, because this Terraform initializing or this provider, what we got here in the directory. So basically when the Terraform initialization has been completed, we got a directory called .terraform, and we have all the files and everything related to the provider here. And it is not advisable to put this directory into the code repository in the Git or the Azure DevOps repository or somewhere, because this file is very large. Even though if you are trying to push it, it will not work in most of the repository cases, because they do have the limitation of the per file size. So anyways, it is not advisable to push it into the code or include it into the code. So it is always advisable, if you are using the Git, then use the git ignore file to ignore this file. So that is basically for the version control system. So yeah, you can just simply ignore this directory. You can delete this directory whenever you want, because whenever next time you are running the Terraform initialization command, it will download it. So it is advisable to add the Terraform log.scl file, because next time when you are running the Terraform init, it will download the same version of the Terraform. Because we didn't mention any version, we didn't mention anything. If I go to the Terraform log.scl file, you can see there are some hashes value as well, which is identified for this specific version itself, this specific provider itself. So next time when you are running the Terraform init, and if you already have this file, then it will always keep initializing and downloading the provider 4.28.0 and with the same hash value. So you can have this file, but you shouldn't have the .terraform folder in your code repository, and it is not advisable to keep it over there. But the log.scl file should be there, and that is up to you how you are managing your code and all. But for our session, the Terraform provider has been downloaded and installed with the help of the Terraform initialization command, and we got two things here. One, terraform.log.scl file, where we can see the complete registry detail So the complete registry detail is registry.terraform.io/hashikop/azure the version of the provider and the hash value of the provider. Okay, and the another thing which we got is the Terraform folder. Let me just open it into the file explorer so it will be more easy to see what do we have in that folder. .terraform folder, we do have providers, we do have registry, we do have HashiCorp, and then we do have Azure RM. I have mentioned like we can have more than one provider. If I didn't, but so I'll just let you know that we can have more than one provider in the same Terraform code. So as I have mentioned before, in the benefits of the Terraform, you can use the same code or same configuration file to deploy the resources in AWS and Azure as well. And it's not just about the provider will have the cloud. There are some other options as well, other functionality as well available with the providers. Like I wanted to generate some random password. So I can have the random provider to generate the random password and call the random resource block. But that is something like on top of that. So we can have more than one provider, and that's why you can see the folder structure is like the provider, and then you can have multiple repository if you're downloading the provider from different repository. Then you have the HashiCorp, Azure RM, because we are downloading only one. The version is 4.28.0. I can go there and it's Windows AMD 64. Based on my current system, it is automatically detecting which version I have to download. So AMD 64, and this is the same version which we have downloaded for the Terraform CLI itself. And now you can see the file size is like eventually grown, because when I initially started working on the Azure, the provider size was somewhere around 100 MB at that time. But now it's like the Terraform is growing and the Azure with the Terraform is also growing. So now the file is 220 MB. So this exe file, and then we do have this license.txt about all the information about the licensing. So these are the file which we do have in the provider, and this is the actual provider. This exe file is basically a code. This code is connecting your cloud provider from the Terraform. So whenever we are writing, like we have written this code in the main.tf file resource group. What Terraform provider.exe is doing, basically it is converting this resource block into the format of the API call. So we can deploy the resources in Azure using the API as well. We do have the Microsoft documentation. We can use the API call to deploy the Azure resources. What Terraform is doing, or what Terraform provider is doing, is converting this simple block, this very simple block, in a format of API and calling the API from here and deploying the resources. But before doing that, it is also checking the state file. It is also checking the Azure itself, like if the same resource group is already there or not. The name of the same resource group is already deployed or not. So it is doing all the checks and validation before deploying the resources, and then it is converting it into the API call. There might be possibility, I don't know like what's behind the code or what's behind the provider.exe, but my assumption is this code is basically converting into the API format, and the Terraform provider is maybe doing some get API to check if the resource is already there or not, checking with the state file, comparing it, and then deploying the resources. So this is how basically a provider is working, and with the help of the Terraform initialization, we can simply, whatever the version or whatever the provider block we do have, we can simply just download that provider. So this is how the provider fetch and find and installation has been done, and these files are important when you are running the Terraform in it. If you deleted this, then you have to reinitialize it. You can keep the log.scl in your code repository, but it is not advisable to keep the .terraform, and you're not able to do as well because most of the code repository are supporting only 100 maximum 100 MB of file, and our file for the provider is more than 220 MB something, so you'll not be able to do it. So that's all about how the Terraform initialization command is fetching and finding the provider and downloading it. And this is what we are getting after the download. So that's all about the Terraform provider. If you have any question, you can just put it into the comment and I'll try my best to answer it as soon as possible. See you in the next lecture. Hi, welcome back. So in this section, we are going to talk about provider version management. In our last section, we saw how to download and fetch the provider, how to write the provider block, but we never mentioned which version we want for that particular provider. So we are going to see how the provider version management can be handled on the Terraform. So let's have a look. In our last section, we saw how to write the provider block. So this is something we have written in our last section. So this is how we are downloading the provider. Now let's see how we are going to manage the provider version. So to manage the provider version, the very first thing which we have to write is the Terraform setting block. So to write the Terraform setting block, we can just simply use the Terraform and then the opening curly braces and the closing curly braces. So here in the Terraform setting blocks, we can manage like Terraform related settings, and we can also mention like which particular version of the provider we want and from which registry it should be downloaded, just in case if we are not using the default registry of HashiCorp. So let's have a go. Then we have to mention the required provider sub block underneath of that Terraform setting block where we are mentioning required providers. Then again the curly braces open and close, and then we are mentioning which provider we wanted to manage or the version of the provider which we wanted to manage. If you can see, we have this Azure RM, and this is a key value pair, so we always have to make sure we are putting the equal to sign in between of this key and value. So Azure RM is key, and then the value we can mention in the curly braces. The first thing which we have to mention is the source from where this particular provider should be downloaded. So Azure RM is the official HashiCorp provider. So we can mention the HashiCorp registry / Azure RM. So HashiCorp is registry in this case and provider is Azure RM. In the second line, we'll have to mention the version. And like other versioning system, we do have the major version that is 3. And then we do have the minor version that is 7070. And then we do have the patch version that is 0 in this case. And if you can see, there is a special character in front of the version. This is something we call version constraint. And we are going to talk about what is the meaning of that version constraint and why we are using this only this sign or what other signs we can use in our next section. So this is how we are making sure like which version we wanted to download for the provider. So in this case, the 3.70.0 of Azure RM version will be downloaded. So this is how we are managing or we are maintaining the version of the provider, and we can make sure only this version or based on the version constant which we are going to talk about in our next slide, we can always make sure like which version should always be downloaded whenever I'm running the Terraform initialization command. Why we are using the version? Why we are not using the always like the latest one? So like any other application, the versioning here is also coming up with the new changes. And there might be possibility those changes are maybe breakthrough changes which might impact your code, which might impact your Terraform configuration, which might impact your actual infrastructure if we are not making it constant or if we are not fixing a specific version. So let's assume there is a new version coming up for the Terraform provider with some new functionality which we don't want to adopt. But with the new latest version, it will come up and there might be possibility our code is going to be break because our code is not, we didn't write that particular code with all those options which are coming up with the new version because those options were not there at the time of this version. So it's always a good practice to make sure like we are using a specific version or we are always using a required provider and mentioning the version which we want. So whenever the new version comes up, we go through the documentation, we see all the things. If we want to adopt it, if we want to utilize it, then we can always update the version and make sure we are updating all the Terraform configuration code based on that. So this is how we are writing a Terraform setting block to make sure we are using the required providers. And now if I if I run the Terraform init command, we'll see what's the result. So in our last section, we saw it downloaded a different version, the latest available version. Here, if you see the Terraform initialization command, you can see the provider version of 3.70.0 was downloaded. Yeah, so in last section, we talked about the version constant, or we just have a look like what is the version constant. In this section, I'm going to explain why we are using those special character when we are using the required providers block with the specific provider version. So let's have a look. The first thing we can use is a version constant instead of that special character which we saw in our last example. We can always use the equal to. Equal to always allow you the exact number of the version, and it cannot be combined with other conditions. So like if you always want 3.70.0, then you can use the equal to sign, but we didn't use in our example, so I'll let you know why and what is the purpose of the sign which we used in our example. But if you don't want like a different version or maybe like a latest or one minus one version, then you can always use the equal to for the exact number of the version. Second option is not equal to sign. So you can always exclude that exact version. Like there might be possibility that particular version is impacting your code and you don't want to use that version, and you should always use the latest one or whatever the other version you want. So you can always use the not equal to sign in front of your version. And then we do have the comparison against a specific version. So we can always use the greater than, like I want every greater version of 3.70.0, then I can use the greater sign. So whatever the version greater than the 3.70.0 will be available, will automatically download it. Or I can use the equal to and greater than and not equal to. So there might be possibility like I wanted to restrict the version based on the condition. So that is also can be done. And one of the special sign which we used in our example is this one. So we can always use this sign, and I would say like in my cases in production environment, most of the time we are using this sign. Why we are using this sign? Because this sign, what this sign is doing is it is using the rightmost version component to increment. So let's assume we are using the 3.70.0, but there will be some patch version going forward gonna be released like 3.70.1, 3.70.2 or something like that. This sign means it will always increment the rightmost digit. So if there is a patch version available, the next patch version available, then it will download and adopt that next available version. If you can see the example, 1.0.4 allowed Terraform to install 1.0.5 and 1.0.10, but not 1.1.0, because 1.1 is not rightmost. Rightmost is 1.1.0. So last digit of your version. If you're not writing a complete one, if you are not using the patch version, if you are just using the major and the minor version like 1.1, then it will always adopt or will allow Terraform to install the 1.2 and not the major version. So it depends on you how you wanted to manage it. My personal recommendation would be always use the 3-digit one, like including the patch version, and always use this sign. So if there is a new patch version, it will automatically be installed, because generally the patch versions doesn't have any breakthrough changes. They are not breaking your code. It will, it most of the time it might have just some security conditions or security updates or something like that. So it always a good practice to use the patch version or latest patch version if you don't want to use the latest minor or major version. So you can use this sign, and one of the reason I put this sign in the example is because most of the production case we are using this sign, but it depends on you, like how you wanted to manage. If you don't want it, then you can use the equal to sign, and you can always use the exact version of the Terraform provider. So that's all about the Terraform version management and version constraint. Thank you. Hi, in this section, we are going to talk about Azure Provider authentication methods. In our last couple of sections, we saw how to use the provider, how to download and fetch the provider, and how to manage the version of the provider. What provider is doing is, it is interacting with the Azure. So when it is interacting with the Azure, it needs to be authenticated. Then only it will be able to deploy the resources to the Azure. Even if we are using the GUI mechanism to deploy the resources, first we have to log in, and based on our authorization and authentication only we can deploy the resources. Similarly, using the Terraform to deploy the resources, we need to authenticate the Azure. And to authenticate it, we have to make sure we are using a proper authentication methods, and those methods are depends on the provider. So if we are not talking about the Azure and maybe some other provider, that time also they do have their own mechanism to authenticate. Like if you are using the AWS, then there might be a different mechanism to use or to authenticate the AWS through the Terraform. But in our case, in our section case, Azure provider, how we can authenticate it, we are going to see in this section. And there are multiple methods which we can use to authenticate the Azure from the Terraform using the Azure provider. So let's have a look. The first mechanism or first common or most used mechanism we do have to authenticate to Azure from the Terraform is the Azure CLI. This option most of the time we are using when we are using the Terraform locally, not with the CI/CD. So if I'm using like to deploy the resources through the Terraform from my laptop, that time I can use the Azure CLI. What Azure CLI is doing is we are authenticating the Azure using the Azure CLI, and Terraform by default is using the Azure CLI mechanism to do the authentication from the Terraform to Azure as well. So if you have already logged in with using your Azure CLI, then the Terraform will automatically use that mechanism and automatically do the authentication. So we don't have to explicitly or especially mention like how it is going to be authenticated. So it's a default mechanism, we can say. If you have already logged in through the AZ login and you have selected the subscription, then by default Terraform will use that subscription to deploy the resources. This is something was happening before the version 4.0, before the Azure Provider 4.0 version, that the default subscription which you have selected using the AZ command will be automatically selected as a default to deploy the resources. But after the version 4.0 of Azure Provider, we have to explicitly mention the subscription ID. And that's why if you have seen the previous example, we never mentioned the subscription ID in the provider block. But if you're using the latest version of Azure Provider, that is 4.0 and later, then you have to mention the subscription ID over there. So let's have a look. So far, we have used the provider block with Azure RM and we didn't mention any subscription ID. But if you are using the latest version, and if you are using any version after the 4.0, like what we are using right now is 4.14.0, so we have to mention the subscription ID over there and we have to select our subscription ID. So nowadays it's not automatically or by default, it is taking the default subscription based on the AZCLI command. Instead of that, we have to mention the subscription ID over here. So once we have mentioned the subscription ID, then we can do the AZ login and then it will ask you for the credential and everything. Once you have successfully logged into the AZ, then it will automatically take the AZ CLI authentication mechanism by default for the Terraform, and we don't have to mention anything anywhere. We can just come and we can run the Terraform init command, and then we can run the Terraform plan command, and it will automatically authenticate the Azure using that AZ CLI as a default mechanism. So this is how we can use the AZ CLI for the default authentication mechanism if we are using it locally, like from my laptop or from your laptop. But if we wanted to use it as a automation, as a CI/CD pipeline, then we do have other mechanism which we are going to talk about in our next section. So the another authentication mechanism which we do have with the Terraform is authenticating using service principal. So as you're already aware about the Azure, you might be already familiar with the service principal. So service principal is the another way to authenticate the Terraform to Azure, or to authenticate the Azure from Terraform. So let's have a look how we can use the service principal to authenticate Azure from Terraform. For that, we will have the same provider block, but with the provider block, we have to mention or we have to configure an environment variable, and the default environment variable name should be ARM client ID, where you are going to put your service principal ID, ARM client secret, where you are going to put the secret key of your service principal, tenant ID, and the subscription ID. So if you are setting up this variable, this environment variable is a default in your pipeline, in your automation, in your like whatever the automation mechanism you are using, you can just configure this environment variable and Terraform will automatically use it. Because this environment variable, Terraform automatically finding into the environment variable with this name, if it found it, and if you have set up it, then it will automatically use this mechanism as a authentication using the service principal. And then you can run the Terraform init and the plan command, and it will automatically authenticate it from the Terraform to your Azure. The another way is to authenticate using the service principal. If you don't want to use the environment variable, then also what you could do is in the provider block, you can explicitly mention the client ID, client secret, tenant ID, and the subscription ID, what we have seen in the environment variable. So you can also put those values in the provider block. And then you don't have to configure the environment variable. You don't have to do the AZ login. It will use this client ID and secret to authenticate the subscription and the tenant. And then you can deploy the resources from the Terraform. But to me, this method is slightly not secured because you are putting your client secret in a plain text. So either you are using some way to like secure it, to maybe encrypt it. By default, Terraform doesn't have any encryption method, but if you are using this mechanism, then you have to make sure you're using this secret value uh, in a more secure way, because by default it is a client secret and you're mentioning over here it's in the plain text, so it's not secure to me. So either you have to make sure this provider file or something like that, you have to make sure it is secured or nobody has the access. Otherwise they will get the client ID and the secret, and whatever the whatever the authorization you are providing to this client ID or this service principal, they will get the same access to your Azure portal and do whatever they want. So just make sure if you are using in this way, then nobody has access to this particular file or these values. Or you can use the variable or other mechanism which we are going to talk about. So that's all about the using the service principal to authenticate and using the Azure CLI. There are a couple of more methods we do have to authenticate Azure from the Terraform. You can do the authenticating to Azure using managed service identity, like the virtual machine you are using to run the Terraform command. You can use the managed service identity, and you can provide the like access to that service identity to your Azure, and then it can also be done. But there are a couple of more mechanisms which or more methods you have to configure while doing it, and you can follow the Terraform documentation for that. The another way to do it is authenticating Azure using a service principal and a client certificate. The last mechanism which we saw using the service principal, it was with client secret key, not with the certificate. But you can always use the client secret as well or client certificate both to authenticate Azure from Terraform. And there is another way to authenticate Azure is using the OpenID Connect. So I'm not going to explain each mechanism over here because these are like some special, in some special cases we are using this mechanism to authenticate Azure. But most of the time, if we are using it locally, then we are using AZCLI. If we are using the CI/CD pipeline, that time we are using the service principal. Or in some cases, you might use the managed service identity. So you can always follow the Terraform documentation for those authentication methods. So yeah, that's all about the authentication methods for Azure Provider, which you can use to authenticate Azure from your Terraform to deploy the resources. Thank you. Hi, so in this section we are going to talk about how we can use multiple provider configuration with alias. So far we have a look like how we are using the provider, how we can configure the provider, how we can write a provider block, and as I have mentioned in our previous section that this new 4.0 version onwards you'll have to mention the subscription ID as well. So let's assume I have a scenario where I want to deploy the resources in a hub and spoke both. I'm using hub and spoke topology, and I wanted to deploy the resources to the hub subscription as well as to the spoke subscription. I do have like a different subscription, and I wanted to do the deployment using the same Terraform configuration code or using the same Terraform configuration folder to the hub subscription as well as to the spoke subscription. Then how I'm gonna do that? Because in the provider configuration block, I can use the subscription ID only once. And whatever the subscription ID I'm going to use, the resources will be deployed to that subscription only. Now I wanted to do the multi-level subscription or multi-subscription level deployment. Then how I'm going to do it? Or let's assume I'm using the Azure deployment as well as the AWS deployment from the Terraform. Generally, we don't use it, but let's assume maybe not AWS or some other provider we are going to use with Azure in combination with Azure. Then how we are going to do that? How we are gonna segregate the blocks or the resource blocks and the other blocks, like it should go to this provider and that resource block should go to the another provider. So that is something we are going to see in this particular section. There is a term called alias which we can use to configure the provider block and provide a naming convention or a alias to that particular block, which we are going to see, and we can use that provider alias configuration to deploy the resources in a multiple subscription or multiple provider in short. So let's have a look. As I have mentioned, first we are going to configure the same thing, Terraform required provider, because I wanted to make sure the version is whatever the version I'm going to use, like 4.14.0, then it should be the version in my case. And then we are going to configure the provider subscription ID and similarly what we did in our last section. But now let's assume I do have a hub and spoke both, and I wanted to make sure like hub resources should be deployed into the hub only and the spoke resources should be deployed to the spoke subscription only. Then how I'm gonna do it with the alias, let's have a look. The first thing we have to configure in the provider block is alias. So let's assume this subscription ID belongs to the hub subscription. So I can do the alias is equal to hub. So whatever the name I want, I can use it. It's not necessarily it should always be hub. You can use whatever the name you want. In my case, it makes more sense to use the hub. So that's why I'm using the hub. Don't get confused about it. And I'll configure or I'll write another provider block, and that provider block I'll configure as alias to spoke one, because I might have the multiple spokes. So first I'll configure the spoke one. Similarly, I'll do the third provider block where I'm gonna put the alias is spoke to, and every provider will have its own subscription ID tagged to it. So now these three providers will work together to deploy the resources. So this is how we are going to configure on the provider block level, but that is not the end. We have to make sure like when we are writing the resource block, we'll have to define like on which particular provider or the subscription that resource should be deployed. So once we have configured the alias in the provider block, then we can write the resource block, and generally the resource group block for like creating the resource group, it will be look like this. You have to provide the name and the location. I think we already saw it in previous window or previous section, one of the previous section. So let's have a look what we are going to change it. So it will be go to like hub, because it by looking at the name, it seems like it's a hub resource group. So what we will have to do is we'll have to write another line called provider as the argument, and the value will be Azure RM.hub. So Azure RM is the provider name, what provider we are using, and hub is a alias. By using this particular argument value, we can make sure this resource group will be deployed into the hub provider and into the hub subscription. Similarly, we can do the resource block or resource group for the spoke one, where the spoke one RG will go, and we can do the similarly for the spoke two. And we can just simply mention in the provider the name of the provider and the alias of the provider. And this is how we can use the alias to use the multiple provider configuration to deploy the resources in a multiple subscription or in a multiple provider. So most of the time when we are deploying the resources in a multiple subscription, we are defining the provider block for each subscription. We are configuring the alias, and at the time of writing the resource block, we will mention the provider and the provider name and the alias. So the Terraform will move or deploy that particular resources into that subscription. So that's all about the multiple provider configuration with alias. And with this section, we have completed our provider configuration or provider section, the whole section. And from the next one, we are going to talk about the next topic, that is the main commands. Hope you guys have enjoyed it. And if you have any question, just put it into the comment. I'll make sure I'll answer your query as soon as possible. Thank you.